Well, hey, living environment fans, we're back for another day, Thursday, here in January, the 5th of January. And of course, we've been studying cells, and we're going to move into studying microscopes and how we use microscopes to learn about cells. All right. Another quick reminder, of course, our midterm exam on the 17th and 18th. And don't forget to take care of yourself. Look back through your assignments and make sure that you don't have anything missing, right? The quarter is coming rapidly to an end.
All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class. And he's super cool. It's Mr. Kovacs class.
Cells are small. They're small. In fact, you did an activity yesterday, right? And yesterday, or the last couple of days, you made 3 cells. You made one that was big, one that was medium, and one that was small. And you calculated the ratio between the volume and the surface area. And you found that even though that this has the biggest volume and the biggest surface area, the little one has the greatest ratio of volume to surface area. That means the amount of stuff on the inside is serviced by the most cell membrane. So cells, by definition, need to be small because they're limited by surface area to volume ratio. Right? So cells are small because of the surface area to volume ratio needed to stay alive, to do all of the life functions with the cell membrane. Some of the biggest cells out there are one-celled organisms, protists, like amoeba. Proteus is the biggest cell. Giant amoebas, paramecia are pretty big. In terms of human cells, you'll never find a bigger cell than a human egg cell. It's a pretty big cell for sure. Cells by nature have to be smaller. Prokaryotic cells, like this E. coli bacteria, are really small. I mean, they are dwarfed by your own cells. In fact, mitochondria, the organelles inside of your cells, are about the same size as one independent E. coli. They're teeny tiny, right? And of course, there are things smaller than cells that have impacts on life, like viruses, for example. Viruses are really small, right? And then other cell parts, proteins and RNA molecules, those are super small as well. But we looked at cells. Cells are limited in size due to their cell membrane. Now, if you think about it, one of the reasons why eukaryotic cells can be so much bigger than prokaryotic cells is because their organelles are, in fact, in turn membrane bound. Okay, so it's like they're a bunch of small little bubbles inside of the big bubble. So the whole big bubble doesn't have to service all of the cell membrane that you can, right? Like the mitochondria's got its own membrane. So it's like a little baby cell living independently inside of a bigger cell. So it does its job without worrying about what this cell membrane is doing. And if that makes sense to you, great. If not, don't worry about it too much. But that's one of the reasons why eukaryotic cells can be so big. And of course, eukaryotic cells, we know how they're built by looking at them with microscopes. And that's what we're going to study for the rest of the week. And we know about them because microscopes have let us see inside to see the various organelles. The standard light microscope is what we're going to use in class. Light microscope has some limitations, right? It can only magnify so much because it uses light. Once you reach a certain magnification, you lose what we call resolution. And it's hard to get good, clean images. But they're practical because they're fairly inexpensive, and they allow us to see specimens, at least things that are small that light can pass through. The electron microscope, so work pretty much the same way, except for instead of light, they use electrons to take pictures. Limits, of course, is that they're kind of big machines, but they also are very expensive. Another couple of limits that I talked about in class yesterday is that when you put a specimen in the electron microscope, you have to remove all the air from around the specimen in order to take a clear picture. That means your specimen has to be placed in a vacuum, and very few living things can survive that. So unfortunately, we're limited in being able to watch living things live under an electron microscope. However, we can see thousands of times greater detail with the electron microscope. So this week we're going to be studying cells using light microscopes. We'll be using micrographs or pictures taken with electron microscopes as well. All right, so if you have lab today, you're going to start that. If not, you start it tomorrow.